Good morning, Bluffview. Hi, Miss Molly, Miss Brianna, and Miss Anna, and all the kids, of course. Wish I could be at Bluffview, but because of the strange things going on in our world, first of all, I hope everybody's staying safe, wash your hands, and do some reading at home. So I thought I'd bring you some science news for today. This isn't news, this is actually almost 100 years old, some of this stuff. So we're going to go take a look at some trees today, because we're going to do something outside, since I can do inside stuff at Bluffview, but we can't do this at Bluffview, that's for sure. Wait till you see what I'm going to show you. So we're going to go outside and look at two really big trees. We're going to measure them with a ruler and then count the tree rings, and then we're going to see how they compare to each other by doing a math problem. So I'm going to try to do something here that's for every grade, from 1 to 6. So grades 1 and 2, you'll be able to do the first couple columns on the back side of this poster board. Grades 4, 5, and 6, you'll be able to do all of it, and you'll have a little bit more understanding of what the whole thing is. So this is one lesson for everybody from grade 1 all the way up to 6. And we'll go outside. It's a nice sunny day, so we're going to go outside and look at two really big, really heavy trees. Okay, so here's our first tree. This is a pine tree. Now you might say, wait, that's not a tree anymore. Used to be a pine tree. And it actually fell right on Peter, Emmy, and Laney's car when it fell down. So that's a whole nother story for a whole nother day. But it was quite a scene. And they were here when it happened. So you can certainly ask them about it. But this was a really big pine tree. So we're going to measure it now. Come on close and we'll measure it. We're going to hook the ruler to one side of the bark and bring the ruler over to the other side and write the number down of what you see. So get close and see what number you see on this ruler. And the biggest number that I see, if we hold that side down, is 32. Now it doesn't matter if you're an inch off. I'll show you why. First I'll write the 32. 32. Now it doesn't matter if you're a little bit off on this, and by an inch or so, because look what happens. If I go a different direction across the tree, here it's only 30. So it doesn't really make a lot of difference. It's not going to make much difference in our numbers. So we can change that to 31 for an average if that would make somebody better, make somebody happier. So we'll change that to 31. All right. Now the tree rings are a little bit more work. So you got to start right at the middle. Here's the middle of the tree, and they're really hard to see in here. So I just estimated 5. I just estimated 5 out to there. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And you see I kept doing that all the way out till I got to 60 out here. 61, 62, 63, 64, 65, 66, 67, 68. So this tree was 68 years old when it got cut down because it fell on the van. All right? So I'm 65, so this tree was a little bit older than me. Just a little bit, 3 years older than me. That's pretty old for a tree, but we're going to see one that's a lot older in just a minute. So this was a pine tree. And that's a fast-growing tree. So look closely at these tree rings and see how big they are. See how big they are? They're almost, not quite, well, some of them are as big as the Sharpie that I'm writing with, and some of them are quite a bit smaller. So we're going to look, oh, but look at way out here. There's a really big one way out there. So when there's a bunch of little ones, that means there wasn't such good growing that year. When there are big ones, big wide ones, that means the tree had lots of water, lots of sunlight, lots of everything just right, no insects bothering it, no deer bothering it, and it grew really well. You can see that almost all trees, when they get to be really old, they slow down and they don't grow so much as they did when they were young. So the tree grows a lot when it's young and a little bit less when it gets old. Let's go look at another tree. Okay, we're out in the wood pile. And here is a really big old oak tree that I cut down last fall. It had died. It was standing dead, and the wind blew it over. And so the lady who owned the tree asked me to cut it up, so I did. So here we're going to come close and measure the tree first for the diameter. So stretch the ruler from one side to the other. And if you look close, you can see it's about 24.5. Try it in a different direction. There you can see it's 24 exactly. So we're going to write down 24. And there's my 24 for the inches of the diameter. Now we got to count the tree rings. So once again, we're going to go to the center. Now the center of this tree was hollow and kind of rotten. So we have to do a little bit of estimating. Look how little the tree rings are there. If I compare them to my Sharpie, they're smaller than the tip of the Sharpie. Okay, so they're really tiny. So how many could I fit in between there and the center? I just made a guess of 20. So I came out to here and said 20, started counting, 21, 22, and got to here for 30 years, 40 years, 50 years, 60 years, 70 years, 80, 90 years. This one is 100 years old, 110, 120, 130 years old. So we'll call this tree with 130 right there, 132, 132, 133 years old. So we'll write down on the chart, 133 years old. That's really old. That's twice as old as me. That's a long time ago. Let's go back inside and see what we can do with these numbers. Okay, we're back inside. Let's see what we can do with the numbers. Now, most of this is for the bigger kids, but you can all try it. It wouldn't hurt at all to try it. So, oh, look at this. Here's a picture of that story that I told you about earlier. See the black van underneath that tree? That used to be Peter, Emmy, and Laney's car. Let's put that away and forget about that. All right, so here's the numbers we wrote outside. 31 inches, 68 years old. 24 inches, 133 years old. Notice that the smaller tree is much older. And the bigger tree is much younger. Still an old tree, but much younger than this one. So here's what we do. We divide this number divided by that one using a calculator. So let's do it. 31 divided by 68 equals, write the first three digits down, 0.455. Now round that off to one decimal place. That's going to be 0.5. If you keep two decimal places, that'll be fine, just as fine also. 0.5 is an easy decimal. We all know that that's 1/2 inch. That means that this tree, on the average, was growing 1/2 inch per year. In 68 years, it grew 34 inches. Now that's a little bit off because we did some rounding, but it's pretty close to what we wanted. Here's the other tree. 24 on the calculator divided by 133 equals 0.18. A lot more numbers that we don't need. We don't need all those decimals. 0.18 is about equal to 3/16. Now, I knew that. You won't know that, so I gave you this chart at the bottom to look at. We'll look at that in a moment. That's about 3/16 of an inch per year. Let's look at these two colored circles. This circle is a 1/2 inch circle in diameter. That's about how big the tree rings were outside. Remember, they were about as big or a little bigger than my Sharpie when I was outside. 0.18 is 3/16 of an inch. That's the red circle. So they were as small as the tip, if you remember, for the smallest ones, but there were some that were bigger. So this is the average. Anytime we count all these things and do a division like that, that's the average of how this, of what this thing is doing from this, when it was 1 year old all the way up to when it was 133 years old. So this is about how big it was growing each year. Stack those circles up for 133 circles, and you'd get about 24 inches. Stack this one up for 68 years, and you'd get about 31 inches. Again, there's a little bit of rounding involved. Now, the last column of our sheet is guessing what this log out there in the yard weighed. it was 8 feet long. I didn't show you that, but it's pretty easy. Just hold the ruler on one end and see how long it is. Let's go over to the computer and I'll show you how you do this. Okay, we're at my computer. You can see the website that I'm on, and I will show you the URL or how to find this website when we go back to the chart in the kitchen for the last time. We're gonna watch this little box here. That's where I'm gonna put my numbers in, and it's gonna tell us how much that log weighs. So the first thing I'm gonna do is pull this one down and type in, choose the type of a log that it is. So they're alphabetical. Here comes oak. So I'm going to look for northern red oak right there. Click it, and it goes up in the box. Now that's needed because all trees, softwood and hardwood, are different weight. Oak is one of the heavier ones. Now it says the small end of the log, and I already have these in there because I was doing this earlier. So I'm going to put in 24. This log has no taper. It's the same size on the big end. So I'm going to put in a 24 there too. Many logs are tapered as the tree goes on, but this one wasn't. The length of the log was 8 feet long, so I'm going to put an 8 in. How many logs? Just one. And then I'm going to click on calculate, and it's going to show right up above. 1,538 pounds. So that's almost a ton. 2,000 would be a ton. A small car weighs about 1.5 tons. So this log weighs about half as much as a car. That's quite a bit. Let's go back to the kitchen and finish this up. All right, so here is the way for you to find. Type into Google, type in log weight calculator, and this will be one of the sites that shows up. Click on it, and you'll get to that screen that I just showed you. So that's about all I have for today. We'll call this whole chart of what else can you do with firewood besides burn it. So this was a lot of fun with firewood. Remember, zoom back in on these fractions because they're going to need to know these. You're going to when your calculator shows you a decimal, you're going to pick whichever one of the fractions is closest to your decimal and write that down on your results. Now, it would be fun if some of you did find some trees that had been cut down that you could still see the tree rings on. You'll notice on my logs outside, I cleaned the tree rings by sanding them across, just to make it a little easier for you to see. Some trees you don't have to do that anyway, and even if they've been laying outside for 5-10 years, they're still clean enough to read. I just tried cleaning them just to see if it would make it easier. So don't worry about cleaning them. Just see if you can count the tree rings, start at the inside and go to the outside. Try to do this chart and see what kind of numbers you come up with for how fast your tree was growing per year. 1/2 inch per year or much less than that, 3/16 of an inch per year. Fun with firewood, that's what we'll call this. Hey, see you soon, I hope. Stay clean, wash your hands, and have fun at home. Do some reading.